so mad at myself that I didn't check the notes first and realize that I actually had a sample problem in here. So we're going to do sample problem 1 together in this very short video. So draw a diagram showing how sodium ions and chloride ions are surrounded by water molecules upon being dissolved. So this is a really important thing to understand, and it's especially going to help us in the next unit as well. So, of course, when sodium chloride dissolves in water, we produce particles. So I have positively charged sodium ions, which I'm just going to circle like that. And I feel like color coding things here. So I'm just going to make a chloride ion here as well, Cl-1. There they are. Now we have to remember that water is a very polar molecule. So the positive, actually, let's go ahead and write water up here quick. So here's water. I'm going to draw its Lewis dot structure. It is bent in shape. You don't have to draw it bent, but it is important to recognize that just so you could see how to determine partial positive and negative charges. So remember, oxygen is very electronegative. So this side of the molecule, in fact, both of these lone pairs will have partial negative charges, whereas both of these hydrogens will have partial positive charges. And using that information, we can determine how the water molecules arrange themselves around each of those ions. So if the sodium ion is positively charged, that must mean that your negatively charged water molecules, or that your negatively charged oxygen molecules, are more so facing towards the sodium ion. So here, I'm just going to draw some lone pairs, and I'm going to make sure that all of my oxygen molecules are facing the sodium ion here. They're not going to be touching them because they're not bonding, but they are going to have a very weak force of attraction. In fact, I threw that one a little bit too close. So try to draw them just so that way they're arranged themselves facing it like that. All the oxygen molecules should be facing this sodium ion. Again, because positives and negatives attract. As opposed to this chloride ion here, because this has a negative charge, your hydrogen atoms that are comprising the water molecule, they are what is going to be facing this chloride ion here. So I'm going to draw these hydrogen atoms in water molecules so they are facing this ion here. And it all comes down to the fact that positives and negatives attract one another. I actually don't think I've really ever drawn this like this before. It's very difficult to draw actually, but try your best to just show these hydrogen atoms that they are what's closer to the chloride in order to form those. They're called ion dipole intermolecular forces actually, which we're not going to talk about in this particular unit. But you should know that the positives and negatives attract, and that's how they would align themselves. And they're oriented this way. Make sure you answer every single part of the question. This is a good skill to get into in your notes and in worksheets, so that way you do that on tests. Why are they oriented this way? So we could just make a little statement here. So the partially negative oxygen atoms in water surround the sodium ion because positive and negative, say negatives, positives and negatives attract. And you could say that the same thing for the opposite one. So the partially positive hydrogen atoms in water surround the chloride ion, again, because positive and negatives attract. There's that sample problem. I'm sorry I forgot to put it in the video, but hopefully you found this link in the description box below that, so that way you're able to find this. Anyway, let's continue with the notes.